Welcome to today's lesson. I am Siamasaka Kirandens. So I'm going to take you through a lesson in physics. And today we'll look at how to determine the center of mass for a lamina. And so we go through the lesson right away. Well, as you may be aware, times we are asked to determine the center of mass of a lamina. And what's a lamina? Actually, a lamina is a thin sheet of cardboard which is irregular in shape, meaning that for you to determine the center of mass, where actually the mass is concentrated, there is a procedure that we have to follow. And this is what we're going to do today. We'll determine the center of mass of a lamina. A lamina is a thin sheet of cardboard. So how then do we find the center of mass of an irregular shaped lamina? First of all, the first thing we do is that we make a hole H in the lamina so that it can swing freely on a nail clamped on the stand. And so here we make a nail at H, and there is a clamp here, the clamp stand. And so you let it swing until actually it settles. And so number two is that the lamina will come to rest with the center of mass vertically below H. So what it means that you have this plumb line where a weight is tied. The plumb line actually is a string that you tie to the nail, and the other side you tie a weight, and you leave it. When it spins, it is going to move this one and it will rest. And so this is what it means here. And so to locate the vertical line through H, tie a plumb line, which is a thread and a weight, through the nail and let it come to rest. So you let it swing until it comes to rest. Okay? And then draw a line on the lamina from H along the thread to point P. So when it is at rest, you draw a line from this point H up to P, where actually the plumb line is lying. Okay. Then hang the lamina from another point X and draw a line along the plumb line to point C. So next, what we do is that you remove the nail from this point and you make a hole on X, and then you let it swing from this point. And this line would be the one which would be vertical now. The line XT would be the one which would be vertical, because this at point T here, you're going to tie this weight. So in other words, you remove the plumb line, you tie it to point T here, and then this one you tie it there, and you let it be vertical as well. Okay, and so where the two lines HP and XT intersect is actually the center of mass for the lamina. And so where these two lines are going to meet, it means that that's the center of mass for that lamina. And so I thought today we can look at how to determine the center of mass of a cardboard which is irregular in shape. And so here is a question which I've given as a homework that you have to go through. because I'm not going to answer this question because it's actually exactly what we have discussed here. But these questions are always asked. So the question goes as follows. Determine an experiment you can carry out to determine the center of mass of a lamina, which is an irregularly shaped cardboard, using the following apparatus. 1. A plumb line, 10 kg stone, irregularly shaped cardboard, a clamp stand, and a nail. So you describe exactly what we have discussed. Then you would have actually described an experiment on how you can carry it out to determine the center of mass. So for today, there are no calculations. Actually, I thought we'll do this simple exercise for us to be able to determine the center of mass for a lamina. I thank you. I hope you subscribe to my YouTube. Thank you.